2.4 into 10 power minus 12 Newton. So 0.628 divided by 6.28. So remember, mu naught is 4 pi into 10 power minus 7 ampere meter square. So this is the magnetic moment. Hello students, this is SD Sir from the Temple of Excellence, Vidhyaashram Pre-University, Mysuru. A new chapter wherein I discuss problems. So in this chapter, moving charges and magnetism, problems are mainly asked on the concept of Biot-Savart's law, magnetic field at the center of a circular coil carrying current, axis of the circular coil carrying current, and conversion of galvanometer into ammeter and voltmeter. Now, we start solving the problems. The first one. The problem says a proton, so given is a charged particle. So there is a proton which is entering a magnetic field of flux density 1.5 Tesla. So the proton is entering a magnetic field whose strength is 1.5 Tesla with a velocity of 2 into 10 power 7 meter per second. The velocity of the moving proton is 2 into 10 power 7 meter per second at an angle of 30 degrees to the magnetic field. I have to calculate the force on the proton given the charge of the proton is so much. So here is a concept where we are calculating the force acting on a charged particle. Analyze. Not a charged conductor. It is a charged particle in the magnetic field. So thereby to collect the data, strength of the magnetic field is given, B, which is 1.5 Tesla. Velocity of motion is given, which is 2 into 10 power 7 meter per second, and angle of inclination is given, theta, which is 30 degrees. Now, do I know any expression with which I can calculate force acting on the proton charged particle. If I go back to my theory, the force acting on the charged particle F equals QVB sin theta. If it is a charged conductor, yes, it is BIL sin theta. For a charged particle, F equals QVB sin theta, which means Q is given 1.6 into 10 power minus 19. Velocity is 2 into 10 power 7. 2 into 10 power 7 into sin 30. Sin 30 is nothing but half. So, direct substitution, finally we arrive, B has to be substituted into 1.5. Q 1.6 into 10 power minus 19. V 2 into 10 power 7. B 1.5. Sin 30 is half. On simplification, this turns out to be 2.4 into 10 power minus 12 Newton. Simple in simplification. The next one, students. Now, the problem says a wire of length 0.628 meter. There is a wire of length 0.628 meter, which is bent to form a loop, and a current of 2 ampere is passed through it. A current of 2 ampere is passed through it. Calculate the magnetic field at the center of the loop. Very clearly, magnetic field at the center of the loop and magnetic moment of the current loop. I have to calculate the magnetic field at the center of the loop and magnetic moment of the current loop. So the problem says there is a wire. Wire is a straight conductor. Keep in mind, wire is a straight conductor. So there is a wire of length 0.628 meter. Length of the wire 0.628 meter is bent in the form of a loop. The wire is bent in the form of a loop and a current of 2 ampere is passed through it. ಅದೊಂದು ಸ್ಟ್ರೈಟ್ ವೈರ್ ಇದೆ, ಸ್ಟ್ರೈಟ್ ಕಂಡಕ್ಟರ್ ಇದೆ. It is modified as a circle, which means now the circumference of the loop is equal to the length of the wire. By logical assertion, where the wire is bent as a loop, modified as a circle, the length of the circle, which is its circumference, is equal to the length of the wire, which means radius is L divided by 2 pi. That is 0.628 2 into 3.14. So 0.628 divided by 6.28, which is 0.1 meter. So I know the radius of this circular loop, 0.1 meter. I know the current passing through the loop, 2 amperes. Then what is the magnetic field at the center? So the first part of the question says the magnetic field at the center BC is mu naught by 4 pi 2 pi IN by R. So expression for magnetic field at the center. So by theory, we clearly know magnetic field at the center of a circular coil is mu naught by 4 pi 2 pi IN by R. Now substituting here, what is the value of mu naught? Magnetic permeability. So it is 4 pi into 10 power minus 7 divided by 4 pi. So remember, mu naught is 4 pi into 10 power minus 7 divided by 4 pi into 2 into 3.14. Current is 0.2. Number of turns we calculated 0.1. Number of turns is not mentioned. When the number of turns is not mentioned, it means there is one turn in the coil. If N is not given, take it to be 1 divided by R, which is 0.1 meter. Now this 4 pi and 4 pi gets cancelled. This is a simple simplification done using a calculator. So this turns out to be 1.25 into 10 power minus 5 Tesla. SI unit is very important. So magnetic field at the center is 1.25 into 10 power minus 5 Tesla. The problem is still not completed. I have to calculate the magnetic moment. So what is the expression for magnetic moment, students? It is I into A, which is I. A is pi r square. Substitute for I. R is 0.1. So this is 0.063 ampere meter square. So this is the magnetic moment. See, very simple. Just substitution and calculation. The next one. The problem says a closely wound circular coil. There is a closely wound circular coil of radius 10 centimeter. Now if you observe, radius is in terms of centimeter, while simplifying it has to be expressed in meters, and carries a current of 3.2 ampere. So the coil of radius 10 centimeter is carrying a current of 3.2 ampere. If the magnetic field at the center of the coil is 2 into 10 power minus 4 Tesla, magnetic field at the center of the coil is 2 into 10 power minus 4 Tesla. Find the number of turns in the coil, and as usual, again find the magnetic moment of the coil. Collect the data, radius. So radius is 10 centimeter, which is 10 into 10 power minus 2 meter. So the radius of the coil is 10 centimeter, which is 10 into 10 power minus 2 meter. And the current is 3.2 ampere. Now very clearly he says, magnetic field at the center, very much established. Magnetic field at the center of the coil is 2 into 10 power minus 4 Tesla. So magnetic field at the center is 2 into 10 power minus 4 Tesla. I will have to find the number of turns in the coil. The same expression. The moment you come across the term magnetic field at the center, so it is BC is mu naught by 4 pi 2 pi IN divided by R. Now what is that we are calculating? Number of turns, N. So BC is given to be 2 into 10 power minus 4. So this is 2 into 10 power minus 4. Again the value of mu naught by 4 pi, 10 power minus 7, because 4 pi gets cancelled with 4 pi, into 2 into 3.14 into I is 3.2. N has to be calculated. Radius is 10 into 10 power minus 2 meters. So on simplification again, rearrange the terms, modify to calculate N. Here N turns out to be 10. Approximately 9.98 something. Number of turns cannot be a fraction. So approximating, N turns out to be 10. Again, magnetic moment. M is I into A R square. Again, I is 3.2. 10 into 10 power minus 2 whole square. So this is 1 ampere meter square. So this is the magnetic moment. The next problem. Interesting one. In an atom, an electron circulates in a path of radius 5.1 into 10 power minus 11 meter at a frequency of 6.8 into 10 power 15 rotations per second. One atom is there. So electron is rotating the atom in a path of radius 5.1 into 10 power minus 11 meter at this given frequency. My dear students, what is the consequence here? There is an electron which is rotating around an atom. Motion of an electron constitutes what? Current. So we know I is nothing but Q divided by T. Current, rate of flow of charges. Since this is electron revolving in an atom, I equals E divided by T. But what is 1 by time? Very good. Frequency. So F into E. I just wanted to introduce this frequency term here. I have to calculate the magnetic field at the center of the orbit under the notion that current is F into E. Again we know magnetic field at the center mu naught by 4 pi 2 pi I n by R. or magnetic field at the center, mu naught by 4 pi, 2 pi. Now I is F into E, N by R. What is the magnetic field at the center? It has to be calculated. Again, this is 10 power minus 7 into 2 into 3.14 into frequency 6.8 into 10 power 15. What is N now? That is where your theory comes into picture. Atomic structure. If you observe, radius is 5 angstrom or 5 into 10 power minus 11 meter. Where theory says this is the radius of the first orbit of the hydrogen atom. 0.5 angstrom, radius of the first orbit. So N is nothing but equal to 1 divided by R, 5.1 into 10 power minus 11. See, slight conceptual understanding arriving me to substitute in the equation. So when we substitute, this turns out to be 13.4 Tesla. See, very simple on calculation. This is an assignment problem for you all. I'll give you the hint and you will solve. 2 concentric circular coils. Concentric circular coils, each having 10 turns. Each having 10 turns with radii 0.2 meter and 0.4 meter, carry currents 0.2 amp and 0.3 amp in opposite directions. So what is the magnetic field at the center? So they have the same number of turns. So magnetic field at the center will be mu naught 4 pi 2 pi I1n divided by R1 minus mu naught by 4 pi I2n divided by R2. Because n remains the same. So on substitution here, mu naught by 4 pi 2 pi n remains the same. So this is 1 by R1 minus 1 by R2, or even we have I1. So I1, again this is 10 power minus 7, n is the same on substitution. So this turns out to be 1.5 into 10 power minus 6 Tesla. Why minus, students? That is the trigger. Minus because very clearly both the coils are carrying current in the opposite directions. So here you saw problems based on the circular coil and magnetic moment. The next class, I'll come up with higher order problems. Until then, have a nice time. Thank you.